Hello and welcome to a brief overview of the 2020 Collins Aerospace Capstone Project. I'm Nicholas Solom, and the rest of the team is Spencer Marcus, Andrew Gabler, and Matthew Volin. Our sponsor for this project was Michael Veit. Collins Aerospace specializes in aerostructures, avionics, interiors, mechanical systems, mission systems, and power and control. For this project, we dealt with connectivity and how it relates to air-to-ground communications. Our goal was to make the job of investigating issues with air-to-ground communications much easier. To accomplish this goal, our capstone project involved developing a tool that visualizes an aircraft's flight logs geographically using Google's Maps API. Having an automated tool is desirable, as air-to-ground communications occasionally behave unexpectedly. The task of manually investigating flight logs for errors is arduous when done by hand, as flight logs can easily become hundreds of thousands of lines long. Our solution to this problem involves two pieces of software. First, a Python application that extracts useful features from verbose flight logs, and second, a standalone web application that integrates with Google Maps used to visualize and animate the flight. I will start by demonstrating our Python log parser. For simplicity's sake, we built our Python application to a binary executable. Since all dependencies are included in the binary, running our application is as easy as opening the executable. First, the user is asked to input a location file, containing periodic updates to the aircraft's location. Next, the user is asked for a flight log. This is the file containing information on air-to-ground communications. Even for this relatively short example flight, this file is 5.7 megabytes and 129,000 lines long. Finally, the user is asked for a file that provides more detailed information on the ground stations themselves, such as their names and locations. As quickly as that, the user is provided with an output file containing all of the necessary information to visualize the flight at only around 1/4 of the original file size. This information is exported to JSON due to its relative universality and its ease of use with JavaScript, which we use to create the web application. Matthew will now demonstrate how this file is used to visualize and play back the flight.
Now I will explain the web application. This program takes a newly created JSON file from the previous script and plots data as a line within a Google Maps window. Our software grabs a map object from Google and plots data so that it can be easily viewed and interacted with. Here's what the main layout of our web application looks like. On the left is the interactable Google map, and on the right are the main controls provided to the user. Now we will upload our newly created file to the web application. Once the data is loaded, it is obvious to an engineer which areas of the flight had potential problems, such as a red line. Users can click on any point of the flight and view the status of the air-ground communication links at that time. Also, layers can be toggled on or off. These layers include time step points, ground stations, map labels, or ground station connections. This is so that users can view only the data they want to see without other things cluttering the map. Furthermore, every flight can be played back by using our app. Users can see any changes within the ground station connections during the flight as the aircraft moves across the map. You can also change the section of the flight you wish to see played back, the playback speed, or even loop the animation.